Morning students. In our last class, that is in our physics, that is chapter 15 volume 1, we have discussed what is a wave, what is a wave motion, and then we went on to see about the types of waves, and then we saw three types of waves. One is mechanical wave, electromagnetic wave, and third is nothing but matter waves. After studying that, then we went on to study very detail about the mechanical waves. This mechanical waves has been further classified into two types. Let's have a small recap of it, and today we can move on to a new content. Now, in the last class I was discussing about types of mechanical wave, that is types of mechanical wave. This mechanical wave has been classified into how many types? I said it has been classified into two types. The first one we call it as transverse wave. What we call it as transverse wave, and the second one we call it as longitudinal wave. Second one we call it as longitudinal wave. These are the two types of mechanical wave which we have discussed in our last class. This transverse wave propagates perpendicular to the direction of disturbance. This is direction of propagation and this is the direction of disturbance. This is direction of propagation. What it is? Nothing but propagation direction. That it is motion. This is direction of propagation, and this vertical line, this indicates the direction of vibration. From this I can say this: direction of vibration and direction of propagation are perpendicular. What they are? Perpendicular or 90 degree. Then I call it as what kind of wave? Transverse wave. This transverse wave, they are giving a new name for transverse wave, that is also called as traveling wave. What it is called as? Traveling. The another name I am going to give for transverse wave is nothing but traveling wave, because it is moving from one place to another place. Hence it is called as traveling wave. And in which medium you can encounter this transverse wave? I gave example is nothing but, that is all solids. All solids exhibits what kind of wave? Transverse wave. And second is nothing but only on the surface, only on surface of liquids you can observe this transverse wave, and it cannot take place. Very important note: in gas or air it does not take place. Does not take place. This is all about the transverse wave which we have discussed in our last class. Little things I have brushed up, and some more thing is nothing but it has to obey the medium, has to obey these two property. The first one we call it as elasticity, and second one we call it as cohesion force. Force of cohesion, it has to obey. These are the some of the things which we have listed in our last class. The first type of the mechanical wave is nothing but transverse wave, or it is called as traveling wave. In this, the direction of propagation and the particle which is vibrating, they are perpendicular to each other, or 90 degree or normal. In this type of wave we call it as transverse wave. This takes place only in solids and only on the surface of the liquid. It cannot take place in gas or in a air medium. Therefore, the property of the medium should obey elasticity and force of cohesion. Based on all this criteria, we have classified it as a transverse wave. Coming to the second type, that one we call it as longitudinal wave. What we are going to discuss now? Longitudinal wave. In longitudinal wave, I said consider a air column. What I asked you to consider the air column. This air column is made out of number of layers, or it is made out of number of segments. What it is made out of? Number of segments where all the air molecules are present there. Is that clear? Now, using a piston or a pulley, this is a piston. I am having a handle. Through this handle I am pushing it forward. Once you push up, the air which is present here all will be rushed over to this column. Am I right or not? Then in this column you can observe more number of air molecules. Here very less number of air molecules. Similarly, this air column will become, all the air molecules will rush there. Here very less number of air columns. Therefore, this part we call it as compression, and This part we call it as a rarefaction. What we call it as rarefaction. Now, if you see the word compression and rarefaction, then it is absolutely what kind of wave? Longitudinal wave. Here it is called as crust and here it is called as trough. If you see crust and trough, then it is what kind of wave? Transverse wave. Here it is a longitudinal, here it is a transverse. Now coming to the point, this air molecules are vibrating or disturbed in the direction of the propagation of the wave. This is the direction of propagation of the sound and this is the vibration or this is the disturbance that is also taking place along. Here it was perpendicular, here it was along what? It was along the direction of propagation. It is along the direction of propagation. Is that clear, students? It can take place, example for longitudinal waves, it can take place in solids, it can take place in liquids. Here it is only on the surface, but here it is inside also, and then it is nothing but gases. That is nothing but, therefore longitudinal wave can take place in all the three states of matter, whereas longitudinal transverse wave can take place only in two states, that too on the surface for liquids. For what it is? Liquids. And this is for gas. What it is for? Gas. Is that clear, students? Is there any doubt in this? Up to here we have discussed in our last class. And here I gave the another name for traveling wave, transverse wave was traveling wave. Then what is the another name I can give for a longitudinal wave? Is nothing but progressive wave. What it is called as? Progressive wave. The another name for longitudinal wave is nothing but progressive wave. What it is? A progressive wave. This is all about the mechanical wave types. Here crust, trough, here compression and rarefaction. In compression, what happens? More air molecules are crowded, then pressure is more, density is more. Whereas in rarefaction, pressure and density is less. This is all about few things which you have discussed in our last class. Now in our today's class, to understand the wave very thoroughly, I need few basic things which you have to come across. Let me share the basic knowledge which is required for the understanding of this wave. That is nothing but important terms. What it is? Nothing but important terms required to explain the wave. Important terms in wave motion. Let us consider the axis. This is your x-axis and this is your y-axis. This is positive x-axis and this is your positive y-axis and this is your negative y-axis. Is that clear? Positive y-axis, negative y-axis. This point you call it as origin. What do you call it as? Origin. Now I am going to draw a wave. This is the wave. This is the wave. I'm going to call this as a wave. What it is? A wave. It is nothing but a transverse wave. What it is? Nothing but a transverse wave. Now coming to the point. Here, this is the direction of propagation. That is along which axis? X-axis. X-axis, positive x-axis indicates the direction of propagation. What it indicates? The direction of propagation. Where positive x-axis indicates what? Direction of propagation. What it indicates? The direction of propagation. Now what y-axis, positive and negative y-axis indicates means vibration or disturbance of the particle. We call it as, that is depicted in which axis? Positive and negative x-axis indicates the displacement. What it indicates? The displacement. Now see here, from here till here, this is the displacement, this is the displacement. All these are the displacements. This is displacement, this is a displacement, this is displacement, this is displacement. All this displacement of the particle is taking place in which axis? Positive y-axis. Now if you consider here, the vibration of the particle taking place in the negative y-axis. Therefore here it is negative. Again it is positive, positive, positive. This is all vibrations. What it is? Nothing but vibrations or disturbance that is taking place in which axis? Positive y-axis. And here it is taking place in negative y-axis. Arrow marks indicates the vibrations or what? Disturbance of the particle taking place along which axis? Positive y-axis and negative y-axis. Now to understand this, let me introduce few terms which is very essential to understand. Now coming to the point, you people know this is maximum and this is maximum and this is maximum and this is maximum. I call it as A, B, C, D. A and C are called as what? Crust. And B and D are called as what? Trough. What it is called as? Trough. A and C is called as crust. B and D is called as trough. What it is called as? Trough. Now looking into the issue, what I said already, A and C is called as crust, B and D is called as trough. Now coming to the important terms which is related to understand, the first term I am introducing is nothing but wavelength. What is the first quantity I am introducing here? Wavelength. That is denoted by the symbol lambda. This is read as lambda. What you should read it as? Lambda. This symbol is read as what? Lambda. What it is read as? Lambda. First term I have introduced, that is nothing but called as what? Wavelength. What it is called as? Wavelength. And it is denoted by what? Lambda. Now what it is defined as means, it is nothing but the distance between. It is the distance between any two consecutive crust. This is crust. Now next followed by this immediate next crust is nothing but AC. That is, it is the distance between any two consecutive crust. That is from A to C. From where to where? A to C. No sir. It is the distance or any two consecutive trough. Or any two consecutive trough. We call it as, that is from A, B to D. Consecutive means immediately next. After that, what is the next availability is C. The distance between A to C, we call it as wavelength. Or between B to D, we call it as wavelength. This is called as a wavelength. What it is called as? Wavelength. Otherwise, it is also defined as, it is the distance between two consecutive particles which are in same phase. I will explain what is phase in the next upcoming concept. As of you remember, it is the distance between two consecutive particles. Here is also one particle, here is also one particle. Therefore, the distance between two consecutive particles at the same phase is called as what? Means we call it as wavelength. What it is called as? Wavelength. The first quantity I have introduced is nothing but wavelength. What is a wavelength? Means it is the distance between any two consecutive crust or trough. That is between from A to C, if you measure, that is called as one wavelength, or from B to D, if you measure, it is called as one wavelength. Otherwise, if you consider the A and C as particles, then the distance between these two particles that are in same phase, then you call it as what? You call it as wavelength, and that symbol is denoted as lambda. And let us see what is the SI unit of wavelength. SI unit of wavelength, SI unit of lambda is nothing but meter. What it is? Meter. SI unit of wavelength is what? Meter. What it is? Meter. SI unit of lambda is what? Meter. And it is what quantity? Means it is a scalar quantity. What it is? A scalar quantity. SI unit is what? Meter. And it is a scalar quantity. What it is? A scalar quantity. The second term which I am going to bring forward is nothing but time period. What it is? Nothing but time period. It is denoted by capital T. What it is denoted by? Time, which is denoted by capital T. Now for example, let us consider this is called as one wave. From crust to crust or trough to trough, we call it as one wave. If not, from O to P, from O to P, we call it as what? One wave. This is called as one wave. What it is called as? One wave. No sir, I will measure from A to C, that is one wave. No sir, from B to D, it is also called as one wave. Time taken to complete one wave is called as time period. What it is called as? Time period. It is nothing but it is defined as time taken to complete one wave. set up in the medium is called as time period. What it is called as time period, or another definition is nothing but time taken to travel a distance equal to its wavelength. That is nothing but very simple. What is wavelength? From this point to this point you call it as wavelength. Time taken to travel its distance equal to its wavelength, you call it as what? Time period. What you call it as time period. Once again I am repeating, what is time period means? Time taken by the wave, time taken to complete one wave that is set up in the medium, we call it as what? Time period. That is from O to P, or from A to C, or from D to B to D. This time taken we call it as time period. That is nothing but capital T. I am denoting it as capital T. What it is denoted as? Capital T. Therefore SI unit of time period is nothing but second, and it is a scalar quantity. What it is? A scalar quantity. This is the second term which I have brought forward. That is nothing but time period. What it is? Nothing but time period. What is time period means? It is the time taken to complete one wave. To complete one wave we call it as what? Time period. What we call it as? Time period. This is the second quantity which I have introduced. Third quantity is nothing but frequency. It is denoted by nu. This is the symbol which is used to represent the frequency. What it is used to represent the frequency. Now let us see the third quantity, that is nothing but frequency. What it is? Frequency. Now what is frequency is defined as means? It is defined as number of waves. Here one wave like this. How many number of waves? Number of waves produced in 1 second. Number of waves produced in 1 second we call it as what? Frequency. What we call it as? Frequency. Here see here from O to P, this is called as one wave. Like this, how many number of waves can take for 1 second? Then that is called as what? Frequency. That is O to P, or from A to C, or from B to D. Like this, how many waves can be produced in how many seconds? 1 second. We call it as frequency. What we call it as? Frequency. Or another definition I can define it as, it is reciprocal of time period. It is reciprocal of time period. What is the symbol for time period I have given? That is nothing but T. Then nu, it is frequency. What it is? Frequency symbol. Nu is written as reciprocal of time period. That is 1 by time period. That is capital T. Then this is the formula. Nu is equals to 1 by T. Is the formula for frequency. Is the formula for what? Frequency. Then what is frequency can be defined as? Frequency is defined as number of waves produced. What it is defined as? Number of waves produced in 1 second, or it is reciprocal of time period. That is nu is equals to 1 by T. What is nu is equals to? It is equals to 1 by T. And let us see its SI unit. SI unit of frequency. What is the SI unit of time? Second. And 1 by second, that is second inverse, is the SI unit of frequency. The second inverse they also call it as hertz. What they call it as? Hertz. In short you can write it as capital HZ, or in words you have to write it as HR. To SI unit of frequency is what? Second inverse or hertz. That is H. Is that clear? This is the third quantity which I have brought forward. That is nothing but frequency. What it is? Frequency. Now coming to the fourth quantity, that is nothing but displacement. What we are going to see now? Displacement. It is nothing but the displacement. Now see the diagram. Here all this particle, all these particles are getting displaced along the positive axis, if not along the negative axis. This is the displacement that is taking place along the y-axis. Then displacement I am going to denote along the y-axis. This is a function of x-axis and it is a function of time. I will tell you. this particle which is propagating along which axis? X-axis. With respect to what? Time. Therefore, displacement is denoted by y, and it is a function of what? X and t. Then this is written in the general form, that is a sine kx minus omega t plus phi. This is for positive x-axis. This is positive x-axis. What it is? Positive x-axis. And the wave starts from 0, moves forward, backward. Then this is what kind of wave? Sinusoidal wave. That is sine wave. What it is? A sine wave. Therefore, here A indicates the amplitude. This is the maximum displacement. I call it as amplitude. Therefore, this is the expression for this. Here the wave is propagating along which axis? Positive x-axis. Therefore, y of x comma t can be written as what? A sine kx minus omega t plus phi. This is the expression for the displacement of wave. What it is? The displacement of a wave propagating in positive x-axis. In which axis? Positive x-axis. Now, this will be the basic expression for us for the displacement. That is y is equals to x comma t, that is equals to a. I call it as equation 1. What I call it as? Equation 1. No sir, you write in the combination of sine and cos, means I can write it as y is equals to x comma t is equals to a sine kx minus omega t plus b cos kx minus. This is a combination of two waves, that is a having amplitude a and b, sine and cos. This is in the combination of sine and cos. Sine starts always from 0, whereas cos starts from maximum to minimum, that is from plus 1. This is about the sine and cos. Here what is a, what is this, all that I will be explaining now. Now just listen carefully. Here I would have written, this is the diagram, am I right? For that diagram we are going to see the components. Let us see the components. Here y is x comma t is equals to a sine kx minus omega t plus phi. If I write here minus, then it indicates for which axis? Positive axis. If I write here plus, then it is for negative x-axis. The wave propagates in this fashion along the negative x-axis. This is negative x-axis. Is that clear? This y is a displacement. What is y is defined there? Displacement. A is called as amplitude. What it is called as? Amplitude. Sine is called as nature of the wave, whether it is a sine or cosine. Sine means it starts from 0, cosine means it starts from 1. Keep that in your mind. Nature of what it is? Nature of wave, where k is called as wave number and x is direction of propagation, omega is called as angular frequency, and phi is called as phase angle. What it is called as? Phase angle. Therefore, this is the general expression they ask, very important for 2 marks. Write the expression for the displacement propagating along the positive x-axis and propagating along the negative x-axis. In positive means here it becomes minus, and in negative x-axis means here it becomes plus. And what are the terms I have listed here? A stands for amplitude, k stands for wave number, and sine stands for nature of wave, and omega stands for angular frequency, and phi stands for phase angle, where x stands for direction of propagation and t stands for the time taken. What it stands for? The time taken. This is all about the general expression for what means for the displacement, for what it is? Displacement. Now coming to the thing, from the previous chapter I am borrowing what the amplitude A can be written as, means it can be written as from equation 1 and 2. This is equation 2. I call it as what? Equation 2. From equation 1 and 2. 1 and 2 implies A is equals to A square plus B square. This is for amplitude. For what it is? Amplitude. And for phase angle, phi is equals to tan inverse of B by A. I am borrowing from the previous chapter, that is from the oscillations I have borrowed this, where A is equals to square root of A square plus B square and phi is equals to tan inverse of B by A. This is all with respect to the displacement, what it is with respect to the displacement. Coming to the next parameter, that is nothing but amplitude. This amplitude is denoted from the figure. Let me depict it. Yes, here, if you see this particle at this time, this is the maximum displacement. At the mean position, these are the two extreme points. If you consider the mean position, at this mean position, this is the maximum displacement which it can take at point A. All these particles are displaced and this is the amplitude. What it is, the amplitude. But see which is having the maximum displacement. A is having maximum displacement. Then this maximum displacement they call it as amplitude, that is denoted as plus A. Here also this is the maximum displacement, that is denoted as minus A. Therefore what is amplitude is defined as means amplitude is defined as nothing but magnitude, because here it is positive and here it is negative. So that magnitude of maximum displacement, what it is nothing but magnitude of maximum displacement, magnitude of maximum displacement from there of the particle from their mean position, from their mean position is called amplitude. Once again I am repeating, listen carefully. This maximum displacement we call it as what? Amplitude, that is plus A and minus A. This is magnitude wise you have to consider, that is nothing but amplitude. I'll give you examples here. Let us consider this is the wave which has propagated. At this point it takes a value of plus 5 and here it takes the value of minus 5, and plus 5 and minus 5 are called as amplitude. No sir, if you consider here also one particle, its amplitude is plus 3, then which is having maximum displacement, plus 5 is having maximum displacement and plus 5 is called as amplitude. Plus 5 and minus 5 are called as what? Amplitude, because it is the maximum displacement. This is nothing but maximum displacement. That maximum displacement we call it as what? We call it as amplitude. Is that clear? From this diagram I have brought main essential quantities, that is nothing but, first one is nothing but wavelength. Followed by wavelength we went on to discuss about time period. After time period we went on to discuss about frequency. After frequency we went on to discuss about the amplitude. Now coming to the next parameter, that is nothing but wave number. This is wave number. It is denoted by small k. What it is denoted by? Small k. This is wave number in short. If not, you can call it as angular wave number. Now let us see what is the value of k. Now let us consider this is the wave which is going to propagate. From this point to this point you call it as lambda. What you call it as? Lambda. Again it is propagating in this fashion. Is it clear? I am going to consider 2 points. This is point x1 and this is point. This point x1 is measured from O and this point x2 is measured from O only. From where it is measured? O. This is x1. This distance is called as x1 and this distance is called as x2. Where x2 can be written as, if this is x, then what x2 can be written as? x1 plus lambda. From this point to this point I call it as what? One wavelength. And x2 can be written as x plus lambda, that is x1 plus lambda, where x1 is equals to x. So let us see what is a wave number. To find this wave number k, where k takes place in the direction of propagation along the x-axis, we know that y of x comma t is equals to a sine kx minus omega t plus phi, where this is the expression for the propagation displacement of a wave. K is nothing but wave number. I want to obtain the expression for k. Is that clear? Now see clearly, I am going to put x is equals to 0. At starting point, what is the value of x? 0. At time t is equals to 0. If x is equals to 0, Consider the displacement equation that is propagating along the x-axis. Y of x comma t is equals to a sine kx minus omega t plus phi. I am going to put t is equals to 0, then phi also equal to 0 in equation 1. In this above equation I am going to put. If I put it in equation 1, what happens here? Y in the place of t I have to put what? 0. Then x comma 0 is equals to a sine kx minus omega. What is the value of t? 0. Plus phi value is also 0. I need wave number. To keep this alive, I have to make this two quantity as dead. When t is equals to 0, phi also will be equal to 0. That's what I have given here. Then y of x is equals to a sine, here what it is? Kx. Omega into 0, 0. Plus 0, 0. Then it is a sine kx. This is the expression for the displacement of the particle propagating along the x-axis. I'm going to call this as equation A. By definition, see at point x1 is equals to x, and at point x2 is equals to x plus lambda. This is one point and this is another point. At this 2 point, what is the displacement? 0. What it is? 0. No sir, I will consider some other point. Wherever you consider, at these 2 points, by definition at points x1 is equals to x and x2 is equals to x plus lambda, their displacements are equal. Their displacements are equal. What happens to their displacements? They should be equal. Substitute in A. And if I substitute here, then y of x1 should be equal to y of x2 by definition. This is by definition. At point x1 and at point x2, both the points, the displacements are equal. That is what I have depicted. Substitute in A. In the place of x and now x1, I have to write what? X. In place of x1. In the place of x, I am going to depict here a sine k x1 is equals to a sine k. In the place of x2, I have to, this is nothing but a sine k x1 I have written here. I will add one more step for you people understanding. K into x plus lambda. Now kx plus lambda. This is how it turns out to be. In the place of x1, what it is? X. I'm going to write it as x. Then a sine kx is equals to a sine k into x is kx plus k lambda. See here both the side. Here a sine kx, here a sine kx plus lambda k. Here what are the values you can give for k lambda so that both the side it should be same. Here we choose k lambda to be 2n pi. What it to be? 2n pi. Why 2n pi I am choosing means sine of even function, that is 180. It remains sine only. What it remains? Sine. Therefore 2 pi, that is 180 into 1, that is 180 into 2 means it is 360. Therefore always it lies in positive. Therefore k lambda should be equal to 2n pi. Substitute n is equals to 1 and k lambda is equals to 2 pi and k is equals to 2 pi by lambda. This is the expression for the wave number. What it is the expression for the wave number? Where wave number is denoted by k and I am considering the displacement equation. The displacement equation is nothing but this is the general form. I am going to put t is equal to 0, phi is equal to 0 to find the value of k, because here time and phi is not needed. Then the expression reduces to form. By definition at points, these 2 points, the displacements are equal at x1 and x2. At x1 y of x1 and at y of x2. It's seeing this expression x1 at point x1, the expression a sine k x1. At point x2, y of x2 is equals to a sine k x2, where x2 value I have substituted x plus lambda. Then it changes to this form. These two will be equal only if k lambda. What are the values you can give for the k lambda means that is nothing but 2 k lambda is equals to 2n pi. Therefore k lambda is equals to 2 pi and k is equals to 2 pi by lambda. Then its SI unit is given by SI unit of k, that is wave number. What is the SI unit of wave number? Means pi, that is radian, lambda is meter, radian per meter, that is, and it is what kind of quantity? It is a scalar quantity. It is a scalar quantity. This is the next term I have brought forward, that is nothing but wave number. What is a wave number? Means change in phase with respect to distance. We call it as wave number, or otherwise it is also called as angular wave number. Is that clear? This is all about the wave number theory, how it has obtained the form I have shown you. As of now you remember only this. This is very important for 1 marks and 2 marks. What is there? It is the change in phase with respect to the distance. This is about the wave number, calculating with respect to the wave number. Is that clear? Now quantity is nothing but angular frequency. Angular frequency is denoted by omega. What it is denoted by? Omega. Now let us consider the general expression for displacement. Y is equals to x comma t is equals to a sine, what I can write, kx minus omega t plus phi. This is for the wave propagating along in which axis? Positive x axis. Now I want the value of omega. Then I am going to put x is equals to 0 and phi is equals to 0. Put x is equals to 0, phi is equals to 0 in equation 1. If I substitute in equation 1, then I will get it as y of 0 comma t is equals to a sine. What is the value of k here? K into, what is the value of x I have chosen? 0 minus omega t plus 0. K into 0, 0. 0 plus of 0, 0. And it is a sine minus omega t. You people would have studied a property, sine of minus theta is nothing but minus sine theta. This property I am going to adopt here. Then it is minus a sine omega t. This is y of t. This is the expression for displacement in the function of time. In the function of what it is? Time. Now let us consider this is the wave which is going to propagate. Am I right? Now I am going to consider again two time intervals. This is at time t1 is equals to t, and this is the another time I am going to consider t2. Time taken to reach here and time taken to reach. Time taken to complete one wave, we call it as what? Time period. Then what t2 can be written as means t1 plus capital T, that is t plus t. Is that clear? Now by definition, at 2 times interval at t1 is equals to t and t2 is equals to t plus t. See at this point what is the displacement y and what is the displacement y. Both should be equal. Then y of t1 is equals to y of t2. Displacement should be equal. At these 2 points, displacements should be equal. That's what I have written here. Therefore substitute this in equation A. Y of t, here y of t1, and what it can be written as minus a sine omega. In the place of t it is t1, then it is t1. Then here minus a sine omega t2. t1 what you can write? T minus a sine omega t is equals to minus a sine omega. t2 can be written as t plus capital T. See at this minus minus gets cancelled. Am I right or not? And what is left out? A sine omega t is equals to a sine. Shall I multiply inside? Omega t plus omega capital T. Now both sides should be equal. Then what are the values this omega t can take up? Means choose. We choose omega t is equals to 2n pi. Why sorry again 2n pi? Means sine of 180 only will remain in sine. 180 is nothing but 2 pi into 1 into 2 into 3, like that it goes. Put n is equals to 1. and omega t is equals to 2 pi, and omega is equals to 2 pi by t. This is the expression for angular frequency. Or we know that reciprocal of time period is nothing but frequency. Then 2 pi into nu is equals to omega. Therefore, these are the two expressions available for what? Angular frequency. And here its SI unit is what? Pi is radian. Time is second. Radian per second. And it is what kind of quantity? Means it is a scalar quantity. Now the next term I brought forward is nothing but angular frequency. What is angular frequency? Means it is denoted by the symbol omega. This is W with a stretch. Let us obtain the expression for the angular frequency. I have considered the general expression for the displacement. Here I need the value of omega. So I am making k and phi to be 0. If I make this two term as 0, then what I will get here? Put x is equals to 0, then phi is equals to 0. I get this is a expression displacement in the function of time. Then by definition of a two time interval. This is one time interval t1, this is another time interval t2. At time t1 it is t, means at time t2 it is nothing but t plus t. At these 2 points I observed the displacement should be equal. Then on equating I will get this expression. Here both the sides should be equal. Then what are the values that omega t can take? Means that omega t can take 2n pi. Put n is equals to 1, that is for first one. Then omega t is equals to 2 pi. Then omega is equals to 2 pi by lambda. SI unit omega is equals to radian per second. Otherwise it is a scalar quantity. What it is? A scalar quantity. This is the thing we have obtained for angular frequency. Next, let us see the relation between. We are going to see the relation between. What is the relation between omega and k? Here omega is called as what? Angular frequency. And what is k is called as angular wave number. What is the relation between these two people? Let us find it out. We know that omega is equals to 2 pi by t, and k is nothing but 2 pi by lambda. I am going to divide equation A by equation B. If I divide A by B, what I will get there? A divided by B. Consider A divided by B. That is omega by k. What is omega value? 2 pi by t. What is k value? 2 pi by lambda. 2 pi gets cancelled. Denominator of denominator goes to numerator. Then omega by k is equals to lambda by t. We know that reciprocal of time period is equals to what? Frequency. Then omega by k is equals to lambda into nu. This is the relation between omega by k, where lambda by v can be written as, that is v, where v is called as velocity of the wave, or omega by k is equals to v. This is the expression for the velocity, or it is the expression for the velocity. The relation between omega and k, give rise to what? Means omega by k is equals to v, that is velocity. What it is? Velocity. Coming to the last quantity, that is nothing but your eighth one, phase, that is angle, that is denoted by phi. Now let us consider two strings A and B. Both are propagated at the same point. Therefore this is how. If you see at the point, at these 2 points, the waves are starting in the same direction or in the opposite direction. If the particles are vibrating in the same point, then it is called as what? Means we call it as in phase. When a wave propagating through a medium, the particles are at the different states of vibration. Then what happens? There exists a phase difference. If two particles are starting with the same vibration, then it is said to be in phase. Once again I am repeating, if you consider any point, at that point if both the things are starting at the same point, that means they are vibrating at the same point, then it is said to be in phase. If you consider this situation, A, B, This is vibrating in this direction, but this is vibrating in an opposite. At this point you consider both of them are vibrating, but in upward direction positive, and this is in negative. And this is said to be out of phase. What it is said to be? Out of phase. Now sir, if I consider in this situation A, B, this has started sir, and here it goes like this, then there is a phase difference. If the vibrations of the particle are different with respect to each other, then it is called as having a phase difference. What there is a phase difference. Here phase difference phi is equals to 0. Here phase difference is 180 degree. And here it is some phase difference which is not equal to 0 and not equal to 180. That means 0 to 180 degree it lies. Understood? What is a phase difference means? It is defined as when two particles are vibrating in the same phase. They are vibrating in the same direction. Then you call it as in phase. Then what is the phase angle between them means 0. And if they are vibrating in an opposite direction means then you call it as out of phase. Phi is equals to 180 degree. If both are propagating in different vibrating movements, then it is phase difference exists from 0 to 180 degree. Today's video we saw some of the important terms. What are the important terms we have come across in our today's class is nothing but the first one I came forward is nothing but wavelength. What is the first quantity I came forward? That is nothing but wavelength, lambda. It is read as what? Lambda. The second quantity I came forward is nothing but what? It is nothing but it is time period. What it is? Time period denoted by capital T. And third one is nothing but frequency, that is denoted by nu. And fourth one is nothing but displacement. I gave many equations for displacement along the x-axis and positive and y-axis. Positive displacement, negative displacement, and propagating along the positive axis, negative axis. And then we went on to wave number, that is denoted by k. And then angular frequency, that is denoted by nu. Angular frequency, that is omega. Last is nothing but phase angle. These are the terms which we have come across in our today's class. And one more quantity is nothing but displacement, amplitude. 8 quantities I have listed in our today's class, which is very important, and these are the fundamental or base for understanding the waves. For understanding what? Waves. Is that clear? Now coming to the last expression, what is the expression for velocity? Let me do it here. Relation between velocity, what it is V is called as velocity, frequency, that is nu, and then wavelength. This 3 quantities relation we are going to see now. Now see here, let us consider this is a wave. From this end to this end we call it as lambda, distance travel. Time taken for that is nothing but time period. Velocity of this wave is given by distance traveled by time taken. Here what is the distance it is traveling from this point to this point? That is nothing but lambda. Time taken to reach from here till here, you call it as time period. Call it as equation 1. We know that 1 by t is nothing but frequency, and V is equals to lambda into nu. This is the relation between the frequency, wavelength and velocity. Once again I am repeating, let us find out the relation between the velocity, frequency and wavelength. What I have done here means to show a comparison between the relation between angular frequency and angular wave number. But here I have shown the relation between normal frequency and wave length. Here wave number, wavelength, angular frequency, frequency. That's the reason I would have done in this form. Don't get messed with this. This is the wave. Velocity is defined as distance by time taken. Then V is equals to lambda by t. The distance travel and time taken is t, where reciprocal of time period 1 by t is nothing but nu, where nu can be written as lambda into nu. Just to go through all these basic concepts, this 8 I want you to be thorough, and these 2 relations I want you to be thorough. Is that clear? In the next class we can discuss with some more content. Is that clear? Thank you, students.